Okay, we're going to be solving for molarity. Let's look at the numbers that we have. We have a mass. We know what the substance is, so we know we could get molar mass. Always something to think about. And we do have a volume in liters. And we're asked about molarity. And then we think about, do we have an equation to solve for molarity? And we do. We have this equation. And then since this is a solution of sodium chloride, that's what this is right there. We need moles of sodium chloride. And then if we think about what do we already have some of the numbers to put in here, and we do. We have this 5 liters, 1.5 liters could go here. So if I could get this number, then I could solve for my molarity. Well, we already noticed that we have a mass and a molar mass, and so of course we do that a lot. We go from grams to moles using our molar mass. And I'm using some rounded off atomic weights to get this molar mass, but this is the molar mass. Okay, and then I'm going to just basically plug into what I had before. Looks like I just have 2 sig figs because of that volume. So I would read that 0.28 molar sodium chloride. So that's our answer. And then what assumption did I make when I did this? And maybe you didn't catch it, and this really is an assumption. Notice that the 1.5, that's water. And we assumed that that volume was the same as the volume of the solution. And that's not always true. It's not going to be quite true. If you can imagine, when you put something in water, it's going to take up some room also. It may fit in between the water molecules, kind of. It may cause the water molecules to spread out a little, or sometimes it brings the water molecules closer together. So just know that there's that assumption. We don't have additional information to where we could, not make that assumption. And when you go on to General Chem 2, you'll be given more data. Like if we had the density of the solution, we could figure this out. But anyway, that's how you get the molarity.